Hello everyone, my name is Petras Zdanavicius and today I'm gonna talk about serializing and displaying trees. So, intro. I work at the company named One Codex. It's bioinformatics, microbiology company. So, which means we rely a lot on taxonomy trees. We need to display results of various classifications and stuff, and you usually want to show where in taxonomy tree the stuff is. So let's start from the beginning. What is a tree as a data structure? So it's a graph. It's a very specific graph. It's a directed graph where each node can have a zero or multiple children, and each node must have a parent except one node, which is special node named root, and every tree starts from the root. And the nodes without children are called a leaf node or leaves. So this is data structure. And then what is a taxonomy or taxonomy tree? It is a way to classify all the living things on the planet Earth and maybe outside, and that the leaf level is either like species or subspecies level, and if you go up you're just generalizing everything, so it's genus or family level or kingdom, etc, etc. And eventually if you go up all the way you're going to reach the root node. It's an artificial node encompassing all the life there is. So I'm gonna do a live demo later, and I'm gonna use a NCBI taxonomy. It's a data available to everyone. It provides the most detailed taxonomy tree. It contains 2.7 million of nodes. It's a very large tree. So if you study like data structures and algorithms and so on, the way to represent tree in code is usually with a node data structure. Is it either type or struct or class or wherever? And I'm using data class as an example here. So you define one class node, and a node class usually node class attributes can be separated in three groups. So first group is data, anything that node contains. So in my example, there's going to be like name, tax ID, rank, and then the other group is hierarchy group. So children and parent, and the reference itself, the class itself. You can survive without parent attribute. You can define your tree, but practically, especially if you're doing like UI or interactive work, you need parent node. You need to go up. Even like in a file tree, file directory, you want to go up one directory. In like taxonomy tree, you want to go, okay, I have this pieces. What's the family group of this? So you need to go up, up, up. So usually you need parent. You can define it, but practically you need that. And then the third group is metadata or cache data. I like to pre-calculate like x and y coordinates of the tree if I need to display it. And there is a trick. I don't calculate like exact position. I usually do relatives. So from 1 to 0. And if my screen sizes changes, I just multiply. I don't care. I don't need to recalculate new ones. And then you can store other data like color and stuff. So serializing. You have a tree in your memory. You need to put it somewhere or send it to web or do whatever. You usually need to serialize your tree. And there's rule in or like common knowledge in Python. Then if you have a data with only primitives plus list and dictionary, then you can serialize it with JSON and send it to web. And it's false rule. So let's like start with this. So if I have dictionary and another dictionary, and if I like do this thing where I reference each dictionary. It's valid data, but if I import JSON and try to dumps A, I'm gonna get a error. Is a circular reference, like dictionary referencing itself eventually, and you cannot use JSON to dump that. But I can use pickle. If I use pickle dumps A, it works. This is Python conference, this is not web conference, so let's not worry about JavaScript for now, and let's move on. So I'm gonna do live demo of the application I've written. I'm gonna do insane thing that you're not supposed to do in this day and age. I'm gonna actually write code using keyboard, like typing characters. Sorry about that, but that's the way the talk is gonna go. So I prepared a application to render that whole NCBI tree, 2.7 million nodes. It's not very beautiful, it's ugly, but it's to demonstrate a various way to approach that. So let's start. I have a renderer, it's SDL application, which just, let's try to run it. So let's run it. For now it does nothing because I haven't written code. It's gonna render all the tree. So the first start with the similar data structure I was using in my slides. So let's go with reference-based dictionary. I have reference-based dictionary. It's similar to the one in the slides. I'm not using data class. I'm not using pydantic and or so, because all the wrappers around the dictionary is gonna like slow down a lot because there's a lot of nodes. So I'm using just pure dictionaries, and I have I have this one. So I have a function or method I need to implement. I'm already like serialize the data, parse NCBI data, already have the tree prepared as a pickle file, and now I get it here as a root node, and I have a very simple render line. So let's go back to it's referencing itself, which means to render the whole thing, I need a recursion, obviously. So, oh, not this one, not renderers. So recursion, I need step function, accepts node, and I'm gonna call that. Oh, that's bad. I thought I'm better at this. Okay, I need to call that. So for child in node, I'm gonna call render line. It has X, it has Y. Now I have child X and child Y. And I'm gonna use color from the parent. And boom, let's try. Okay, it draws the 3 lines on the left because I'm not calling recursive function. Yeah, so I pass there, and let's see how it looks. It's gonna take a while, like 1, 2, 3, 4, 5, 6. Okay, it's done. So this is the tree of life. It took 1.2 seconds to read input to like serialize data. Rendering took like 5.9. It's very good. Usually it was slower, and total is 7.2. And this is stupid thing to do because there is like 2.5 million of leaf nodes, and Y axis. I'm trying to fit 2.5 million of things into around like 1000 pixels. So, but it demos like working with such large tree. So I needed recursion. I cannot serialize this tree. How to solve? I cannot serialize it using JSON. How to solve that? There is a trick how to convert like self-referencing data structure to like flat data structure, and I call that flat dictionary. So we can open that together, and only these lines changes. Instead of having a reference to the thing, I have integer, and it's obviously some kind of ID. And what kind of IDs? The tree itself would be list of these. So these integers would point to position in this tree. So now instead of having this complex like nested structure, I have flat list of things. And now rendering code would become much more simpler. So if I go for, I can use follow finally in nodes, then another follow child index in node this, then C index, can use this line, boom, boom. Let's try to run this flat. Reading input is done, rendering, it's gonna take similar amount of time. It's done. So I rendered the same tree with a much more simpler code, but it took a little bit longer, which is very strange for me. I don't know why. I don't know why doing for loops is actually slower than calling functions a lot. Maybe this takes a lot, I don't know. So there is no improvement in performance, just the code is simple, but I gain a lot of flexibility by removing nestiness of the data structure. Now I have flat structure, which almost like a database table, and it only contains like simple primitive variables, which means I can start using fancy things like pandas, or in my case, polars. So I'm gonna show you the code I'm converting to flat. Upper doesn't matter. So I'm using pickle to dump all the nodes, but I can also easily just pass those dictionaries to Polar's data frame and use like fast serializing method. This method at the end is just memory dump, and deserializing is just taking stuff from binary file and putting into memory. So it's very, very fast. And I'm gonna go back to this, and let's quit this tree. So I'm gonna use polars. It does nothing, but reading input is very fast. I'm not polars expert or pandas expert or data frame expert, so this is gonna take a while. Let's use print debugging. Okay, so I have data frame. Now what do I need? I need not all fields, but several fields, so it's gonna be select. What I'm gonna select, I'm gonna select coordinates. I need color as well. I need children, and I'm gonna create artificial column named coordinates, it's going to be struct. It's eventually going to be children coordinates. So it's, but for now I'm going to pick my own, this row coordinates. And it's Y. Yeah, I think this is everything I need. So yeah, I have parent coordinates, I have color, I have children indices, and I have coordinates. Now I'm gonna do the main trick. So I'm gonna create another column, children coordinates. I'm gonna take coordinates, I'm gonna implode and gonna use list gather and pass children indices to collect everything. Let's see if that works. Okay, so I took this list and replaced indices with correct coordinates from this column. Hope so. Now, finally, I can filter. Where's my filter? I don't care about leaves, so I can filter that out. And now I can finally select everything. So I need X for current node, I need Y, I need children coordinates, and I need color. Now I can actually explode on children coordinates. Let's see if that works. Okay, so for each child of the same node, I have multiple rows. And now I can actually unnest. See chords. Whoa. This is why I'm not using prompts. I cannot even use autocomplete. And I lost my, okay, so I'm nesting. Let's see. Okay. Now I'm gonna do a bad thing you are not supposed to do. So I'm gonna use for loop in Python and using data frames, which is gonna destroy all performance I gain. But this is the system I have, so iter rows. And I can just render line, pass. Let's see how that works. If it works. Okay. Oh, where is my? Okay, so it worked. It worked and rendered same tree. The reading of input, deserializing, is very fast because it is just memory dump. Rendering took a while, and several seconds were spent like manipulating the data frame itself, and totally it's fastest way to render. But yeah, I was doing the wrong thing. You're not supposed to render as many things using Python. It's slow, and I'm using wrong methods like for eaching everything. But it's still using flat data structure, be it using reference-based data structure. And if do I have time? I have a little bit time, so let's do another coding exercise. So instead of rendering tree, let's calculate number of leaves using all these three data structures. So let's start with ref based one. Again, number of trees using graph. Again, I only have one node, which means recursion. I need step function. It takes node. It returns integer. 0. I'm passing root node. This is not the way to spell it. So if there is no children, I'm returning 1. Otherwise, I'm returning sum of step C for C in node children. Let's see if that works. The number of children is, yeah, almost 2.5 million. Well, number of leaves are here. And it took me 1.5 seconds to calculate that. Now let's go to this naive flat data structure. It's for loops. It's very simple. So if not node. Okay, I need something. And flat. I got same number of leaves, but it took longer. Again, I have no clue why for eaching is slower than recursion. And with data frame, it's gonna be very fast because I'm just gonna like filter on where children len is 0, I think. And just gonna take number of rows. Yeah. And same number, but in like incredible fast speed. So I think this is the end. Yeah, this is the end. So to summarize, there are multiple ways to store trees, and depending on your needs, you need to pick the correct one. Every way to store the tree has pros and cons, though I like flat structures and flat structures rules. So this is the end of my talk. Thank you very much.